Hey everybody, this is your 5/8 Math Excel video, and it has to do with the quadratic formula x equal negative b plus or minus, so that's where it would have a maximum of two solutions. The square root of b squared minus 4ac over 2a, where you have ax squared plus bx plus c equals 0. These letters are just in alphabetical order, just like in other sections where we did something else related to them. So on your first one, you have x squared minus 11x plus 28. So a is 1, because that's the coefficient, b is negative 11, c is 28, and that's how it works. So there's your formula. You do the opposite sign of this term, so it's positive 11 plus or minus 11 squared, which is 121. Remember, a hint would be learn y equal x squared, 1, 1, 2, 4, 3, 9, 4, 16, etc. When I was in school, we had to learn up to 25 squared, which is 625. That's what we had to do when I was in school. We had to do that mentally without a calculator. That's just going to speed things up quite a bit. But 11 squared is 121, and then we go minus 4 times 1, and I don't usually write the times 1, and then times the c, which is 28. So what I always do is I like to work out this inside the square root part on the calculator, and then simplify from there. So if you type in 121 minus 4 times 28, you get 9. And the square root of 9 is 3. So then this breaks up into 11 minus 3 over 2, so 8 halves, which is 4, and 11 plus 3 over 2, which is 14 halves, which is 7. If you do it this way, then your lowest number would be first, and then your higher number would be second. On the next example, we have 3x squared minus 17x equals 6, so we just bring the 6 over and do the same thing. So change your sign of the 17 from negative 17 to positive. 17 squared is 289, and then minus 4 times 3. So this is an example where you don't have 1 as the coefficient, times negative 6 over 2 times 3. So if you work out this part underneath, which is called the discriminant, if you do that part on the calculator, you get 361, and the square root of that would be 19. So then you're going to break it up into 17 minus 19 over 6 and 17 plus 19 over 6. So for this one, you get negative 2/6, which is negative 1/3. For this one, you get 36/6, which is 6. And you put your comma between the answers. On the next one, you have 2x times 3x minus 1 equal 13. So your first step is to distribute the 2x like that. Some people call that the rainbow or arrow method. 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. Then you're also going to bring your 13 to the other side, and you do the same thing. You have your a, b, c, and work it out. Now on this one, when you do this inside part, which is your discriminant, you get 316, which is not a perfect square. And so in this case, if you remember what I recommended before, you're going to say f1 is 316 divided by x. Remember, this is what they call a rational function, but it's also used in inverse variation. So basically the product of these two numbers gives you 316. And you always want to look for a perfect square to simplify your square roots. So you want to look for 4, 9, 16, 25, etc. In this case, the only one we can do is 4 with 79. What that means is it would be square root of 4 times square root of 79, which is 2 square root of 79. So we have 2 plus or minus 2 square root of 79 all over 12. Divide these out, and so you get 1 plus or minus square root of 79 over 6. Remember, on your Math Excel, they want a comma between your answers. And so I put the negative one first, 1 minus square root of 79 over 6, and then 1 plus square root of 79 over 6. So again, these are called the exact answers, which means not rounded. On the next one, it says your class is selling boxes of flower seeds as a fundraiser. The total profit P depends on the amount X that your class charges for each box of seeds. The equation P equal negative 0.5 x squared plus 16x minus 12 models the profit of the fundraiser. What's the smallest amount in dollars that you can charge and make at least $100? So you basically put your equation, then put equal 100, then you're going to move the 100 over so it's negative 112. Then just use your calculator for this inside part. That inside part, the discriminant, gives you 32. So remember, when you're simplifying your square root for that, look for your biggest perfect square. So I would think doing it like 16 times 2 would be best, because you know that's 4 square root of 2. On the other hand, if you just think 32 is 4 times 8, you can say 4 times 2 that way, and you have a pair of 4s. The other way, which is a little more complicated because you're going to have so many 2's, is like this. 32 is really 2 times 16, and if you forgot about 16 being a perfect square, then you would say 8 times 2, and then this is really 4 times 2, and then this is really 2 times 2. And what you do is you circle all your pairs. So you have this group of 2's and this group of 2's. So that would be 2 times 2. And the one I did not circle is this one, which would be square root of 2. So then this gives you 4 square root of 2. Now, when you do this, you get negative 16 plus or minus 4 square root of 2. And there you just want to do it on the calculator, and they want you to round to 2 decimal places. So you have 10.34 and 21.66. Now, you just pick the smaller number, which is the 10.34. So even though there would be 2 answers, in theory, they only want the smallest amount in dollars. So that's your $10.34. On the next one, you have a table which would be useful. It says discriminants and solutions, the value of the discriminant, and the number of solutions. So here you have b squared minus 4ac greater than 0, which would be 2. If it's equal, it'd be 1, and if it's less, it'd be no real solutions, which means you might have imaginary, which, by the way, is on the next section. So here you have 3x squared plus 4x plus 2, and again, I'm just telling you your vocabulary. This would be negative b plus or minus the square root of your discriminant over 2a. So your discriminant is your b squared minus 4ac. So you don't have to do this whole formula, you just do the b squared minus 4ac part. And so this would be 4 squared minus 4 times 3 times 2. When you do that, you get negative 8, which would be an answer because they do want the number, and then they also want to know how many solutions, and if it's negative, it would have no real solutions. On the next one, we have 5x squared plus 14x minus 3. Same process. In this case, you get 256, which, by the way, the square root of that would be 16. Anyway, this b squared minus 4ac is positive 256, and so it'd be two real solutions. The two real solutions basically means it's going to hit somewhere like that, or if you had a negative sign, like that. You could move it left and right across the axis and it still have two solutions, but the idea is it would have to cross twice. On your next one, you have x squared minus 12x equal negative 36. So we want to bring that over to be plus 36 and then do this again. In this one, I got 0, which is one real solution. What that means is, like this one, you might have been able to recognize this as the square root of x squared is x, and the square root of 36 is 6. So this would be x equals 6. So that would look like the one with 6 like that, and just touching once. One solution. The next one says solve through any method. And if we have any method, we've already done a few with the way you know, but since I'm trying to prepare you for pre-calculus also, there's a part where it talks about potential zeros and actual zeros. So for potential zeros, what you do is you have to do q over p. Now q is the same thing as the c variable. You go a, b, c like this. Q is the same thing as the c variable, and p is the same thing as the a variable. What you do is you have to list out your factors. And so to get negative 2, you would have plus and minus 1 and 2 as how you get negative 2, just through multiplying with that plus and minus. And with the p being 9, you would have plus or minus 1 times 9. So 1 and 9. Now what you do is you take all the ratios. You need all your ratios. Now, if you didn't know, potential would be more than you actually have. Because if we have x squared, the most we would have would be 2. But when you have potential zeros, you're going to have several. Like sometimes you might have 4, 8, 16, or whatever. And so what you do is all your ratios of q over p. And so, like, for example, 1 over 1, 1 over 9. So now I used all of my 1s. And then 2 over 1, 2 over 9. And so the 1 over 1 is 1, your 2 over 1 is 2. So these are your potential zeros. Now, the 1/9, the reason why that could help you is because when you graph it, you would see negative 0.111. And you have to somehow interpret that to be a fraction. So the other one would be 2, which is easy. Now, over here I put a note. It's a repeating number. When it's a repeating number, then it means divide by 9. And so even when you're doing 0.3333, that means 3/9, which is the same as 1/3. And so if you have the same number over and over again, like here it's 1 over and over again, so that means 1/9. That's just the way it works. Okay, so there's your introduction to potential zeros and how it could be useful, especially since you're looking for, like, how do you make that a fraction? And so you would think, oh, well, that's 9, so maybe 1/9 or 2/9 based on those numbers. And in this case, it had to be 1/9. Again, since it said any method, you could also use the quadratic formula, which would always work. Factoring sometimes works, etc. All right, the next one says 4x squared plus 5x minus 13 equals 0. Again, solve with any method. And the way that you know for sure would work is the quadratic formula. So you have negative b plus or minus the square root b squared minus 4ac all over 2a. And then just plug in your numbers. So again, a, b, and c, and just do it. Now on this one, the inside the square root part, again, was the discriminant. That gives you 223, which is not a perfect square. 225 would give you 15, but in this one it's a decimal. So if you do this on the calculator with minus, you get negative 2.53, and if you do it with plus, you get 1.28. So those would be your answers. Again, if you prefer graphing and do your x-intercept or 0, you can, because it does say any method. Now, on the next one it says, if a certain cannon is fired from a height of 9.8 meters above the ground at a certain angle, the height of the cannonball above the ground h in meters at time t in seconds is found by the function this. So the key things to recognize are this is a common coefficient, the negative 4.9 t squared. That's pretty common. This one would be your original height, and then this just adjusts it left or right. That's the linear term. And it says find the time it takes for the cannonball to strike the ground. So again, here's your A, here's your B, here's your C. And you just do it. Again, you just round this to the hundredth, and you have negative 0.28 and 7.12. Well, in this case, time cannot be negative because it's not the time before the event, or the time before the cannon was fired. And so you just get 7.12 for your only answer. On your next one, it says, without graphing, determine how many x-intercepts there are. And so that basically means use b squared minus 4ac like our table. So when you do that for this one, you put in a is negative 2, b is 4, c is 11. And just work it out. You have a positive 104, and so there'd be 2. And then you have the same instructions on that one. This one's pretty interesting. I kind of like this one. It says write a quadratic equation with the given solutions. So this time you're given your answer and you have to work backwards. So this makes you think a little bit more. So on this one you have negative 9 plus or minus the square root of 21 over 6. So you could think of this as a puzzle. Remember that if you have negative b in your formula and it says negative 9, that b would have to be positive 9. And if you have 2a equals 6, then a would have to be 3. So those you could kind of get mentally. And then from there you say your b squared minus 4ac is 21. And then just work it out. 9 squared is 81. Minus 4 times a, which is 3, times c, which is still your variable, equal 21. And then what I did is I brought my 21 over, so say 60, bring this over, which is positive 12c. Then divide and you get 5. Then all you have to do is write it in the correct order. It's ax squared plus bx plus c, so that's 3x squared plus 9x plus 5. Equals 0. The other thing that's a little unusual about this one is it is multiple choice, but they have like at least 4 answer choices. I think it's like 6 or 8, and you have to fill in the number also. So I was like, you may as well just work it out and then pick it and fill in the number. So I like that question because it's a little challenging. Makes you think, like a puzzle. Now this one just says solve using the quadratic formula, and that's simple. This one says find the discriminant and the number of real solutions. So again, that's simple. It's the same process as before. Our last one is extra practice C. It says the weekly revenue for a company is R equal negative 3p squared plus 70p plus 52. Use the discriminant to find whether there is a price for which the revenue that's weekly would be $1,800. So you basically set your equation equal to 1,800, bring it over so it's negative 1748, and then use that for your A, B, and C. So you have negative 70 plus and minus the square root of 70 squared minus 4 times negative 3 times negative 1748 over 2 times negative 3. Now, really, you just need the discriminant part, and so that'd be this part. So this part right there is a little extra. So the b squared minus 4ac would be the 70 squared minus 4 times negative 3 times negative 1748. And when you do that, you get a negative 16,076. Since that's a negative answer, then there are no real solutions, which means there is no price for that revenue. Now, again, remember, all your numbers are going to change. Yours might have a solution instead of not having a solution. It just varies. Okay, so keep that in mind as you go through these problems. Have a good day.